Awesome. Hi, okay, welcome to the March edition of the OHDSI APAC community call. I won't take up much time. We're not going to go over any of the typical APAC stuff. Today, we actually are joined by at least 7 presenters that I believe, if I can remember my numbers right, from the OHDSI China team. And they're here to, if you could go to the next slide, please, Juan. They're going to be here to talk about their OHDSI studies that they would like to see if OHDSI can help run and execute. I know we have an order here, but I know Dr. Liu is actually joining us from his surgery room. So I'm actually going to see if he can go first so that this way, you know, we don't take up many more of his valuable time. Okay. Sorry, Wen Shuo, if that's okay.
It's okay. It's okay.
Awesome. Can we skip the slide 11, please? Yeah.
There you go.
Okay, yes. Dr. Liu, do you want to talk about your studies?
All right, very kind of you. Thank you, everyone. Should I begin?
Yes, please.
All right. Good morning and good night, everyone. My name is ㍍Study and I'm from the Department of Plastic Surgery, as you can see, at Zhongshan Hospital Fudan University. I'm also affiliated with the AI Center for Plastic Surgery and Soft Tissue Cancers. Today, I'd like to introduce one of our research projects, association between fasting plasma glucose levels and annual hospitalization, multi-center study using the OHDSI framework. Next page. But fasting plasma glucose is perhaps one of the most common clinical testing indicators we have. On one hand, the current incidence rate of diabetes has reached as high as 10%, which means there is a large patient population. On the other hand, it is a deniable fact that fasting plasma glucose can provide a wealth of clinical information and guide clinical work. We believe that one of the important pieces of clinical information is the prediction of the duration of hospitalization for diabetes patients. This is of great significance for both patients and doctors. For patients, obtaining an accurate prediction of the duration of hospitalization can help them arrange work leave and home care, which is crucial for them to receive social support. For doctors, getting an accurate prediction of the duration of hospitalization can assist them in allocating medical resources and nursing resources in advance, and achieving common goals in medical treatment and nursing. Previously, we searched for the codes. Page 5.
Oops.
Previously, we searched for the codes required for this study. The results demonstrated that our research can be comprehensively described by the standard codes in the Athena database. These codes mainly cover the diagnosis of diabetes, blood glucose measurement, medicine for diabetes, the duration of hospitalization, and the treatment outcomes. Next, please. This is the treatment for the diabetes. These are very common indicators. This will not only enhance the participation level of our research, but also endow it with the greater representativeness. By setting inclusion criteria, we can make our research better represent the hospitalization situations in the real world. We hope that through this project, we can attract the participations of more institutions and provide data on the medical burden in the treatment of diabetes. That's all for this project. Thank you.
Thank you very much. So the way this is going to work is basically we have the presenter, the researcher present their research, right? And then if folks have question in the OHDSI community, or if folks want to provide some feedback on this research, is it even possible? Are there certain things we need to change? What's the likelihood, right? So, so I'm going to open it up to the floor to see if anybody has questions or want to comment on this research. Yes, Chan.
Yeah, if no one raised their hands, we'll gonna be first. So I want to share that the recent demo OHDSI. So if you're gonna go to the atlas-demo.odyssey.org, and then if you wanna if you search the concept IDs, then you can find that how many records are captured in the current OHDSI evidence data network. So you can see that for the fasting glucose blood glucose measurements, we do have more than 20 million records in our evidence network, and then you can see the you can easily identify your feasibility of the study. And I think that about in terms of the data availability, I believe this study has some substantial amount of the data across the network. That's it.
Thank you for that feedback. So Chan, thanks for sharing that. That means this research, at least this particular study seems like it's possible, right? Cynthia, go ahead.
Hi. Yes, I'm just wondering whether it, elevated, there's a, let's see, hemoglobin A1C is another common biomarker for elevated glucose levels, and it better reflects the integrated elevation of glucose over like a month. Have you thought about including that? Over.
Dr. Liu, have you thought about including elevated glucose in
No.
your study?
Sorry, it's hemoglobin A1C.
I'm sorry.
Well, we already considered it just in the duration of our design's research. We believe that the fasting glucose, the merely one indicator, maybe may include all the information we need, because the fasting plasma glucose is the most used marker we use in the clinical practice.
Thank you. Go ahead, Cynthia. Did you have a follow-up there?
No, only that in clinical trials of anti-diabetic drugs, the preferred surrogate endpoint is reduction of HbA1c. So that's it. It's just international, or at least in clinical trial practice, that is a good marker. But if it's not collected often in your databases, then I understand why you don't look at it. Over.
Awesome. Thank you. We'll take that into account. Nicole?
Hey, thank you so much for that presentation. My question really, I think, has been somewhat answered by the slide that's up on the screen right now. I was just thinking about the outcome that you're interested in, and it looks like you want to know how often are they, or how much of the year are they in hospital as a surrogate for healthcare utilization. Is that right? So you'll be looking at how many days in a year they're actually in care in a hospital setting. Is that right?
Yeah, right. It's just what we want to do.
Okay, that it was just a clarification, and you've got that slide up there. I think associating the glucose levels with that outcome may be a little tricky in terms of the timing of those events. So you might want to look at, the exposure period and the outcome period, and really have a think about the timing and the temporal association there, because annual rates are hard to analyze, I guess, and associate with rates of, testing. So thinking through that and that analytic design would be useful.
Well, we can
Thank you.
go through about this idea.
Right.
Okay.
Thank you. Okay, Chi, last question on this one, because I got to move on. There's 6 other ones. Yes, Chi.
So you said at least 2 fasting blood glucose test record, right? Now, if there are more than 2, and how do you pick? Like you do an average of all the glucose test record, or?
Well, based on the time they get this test, if they just go like the very different time, like 1 month ago, we use the earliest one. If they get a very similar time, very short time, like days, I mean in the work, I think we want to, we believe we want to take the lowest one.
Okay, thank you.
No, sorry, the highest one.
Okay.
All right, thank you for that one. I believe you have a second study you want to talk through. So would you like to present on your second one, please?
All right, thank you. Next, I'd like to introduce another one of our project, post-operative LDH levels and their impact on survival in melanoma and other cancer patients. Multi-study using the OHDSI framework. LDH for lactic dehydrogenase is a common indicator in clinical examination. It is mainly included in liver function tests. According to the classic theory, LDH is associated with poor prognosis in many cancers, such as melanoma, gastric cancer, and pancreatic cancer. However, there are always however here. These theories haven't had corresponding practice effect in the clinical field due to the lack of data. We are currently unclear about which malignant biological behaviors of tumor are affected by LDH. Also, we can't establish the relationship between the LDH levels and tumor staging and grading. At the same time, we lacked a systematic understanding of the expressed characteristics of LDH in different cancers. This is exactly why we initiated this study. Previously, we searched for the codes required for the study. The results show that our research can be fully described by the standard codes in the estimate database. This code mainly covers the pathological classification of tumor, malignant markers, anti-cancer treatment. Next paper, please. And the treatment efficiency, as well as the tumor prognosis. Next page. Regarding the inclusive criteria of this project, we emphasize a follow-up period of more than 1 year of patients. Next page, please. Since these 3 types of tumor are highly malignant, a 1-year follow-up can help us obtain a large amount of data without making the inclusion criteria overly stringent. Our main observation indicators are the patient's post-operative LDH level and their prognosis. Through analysis, we aim to establish the corresponding relationship between LDH levels and prognosis cancer. Although there are many subtypes of LDH in clinical practice, we tend to believe that using the LDH that can be detected by virus institutions is sufficient. This will make our research more engaging and give it stronger representativeness. That's all for the introduction of this project. Thank you.
Thank you. Anyone have any comments on this particular study? You can go back like 2 pages to where the criteria was. Yeah, that one.
Yeah, that's.
Anyone have any feedback on this one?
So, yeah, once again,
ahead,
me.
Chen.
We can evaluate the feasibility of the study with the two dimensions. First one is the data availability, and second one is the availability of the standardized data analytic framework. We've developed several analytic frameworks such as characterization, population level estimation, and patient level prediction. And in terms of the data availability, I had some concerns about the availability of the staging information. So even though we have the schema and the vocabulary for stagings of the cancer, but many institutions in the OHDSI network actually do not capture those information in the CDM database. That's the concern of mine.
It's not that we don't capture. I think it's because most of the staging information typically exists in the notes, right? And it's not always parsed. So great feedback there. Cynthia.
Hi. Yeah, I think this is a really interesting study. And in a way, it seems like it's trying to advance a biomarker into maybe a more acceptable endpoint for clinical trials. So I just wanted to make a comment that maybe this is a prototype of other studies that could be done to advance biomarkers into more accepted endpoints for regulatory approval of drugs. Over.
Thank you for that feedback. Anyone else on this particular study? Chi.
I'm trying to understand the objective of the study. Let's say you find an association, right? You find an elevated level associated with the overall survival and PFS. What are you going to do with it, with that information? Like how? Like you're not going to have any treatment decision on that, right? It's not a actual biomarker on the cancer cell that you can target against, right? It's only a damage, or it's an indicator of the cell damage.
This is very good feedback. LDH is kind of a traditional marker, and we all know that the treatment for the cancer advances very fast. They are like PD-L1 or some new drugs in our clinical practice. In this research, we aim to explore the relationship between the treatment and the LDH, this marker. With the big data, we want to know the LDH can practice some treatment efficiency of some new drugs. With this data, by measure the LDH level post-operatively, we can predict which kind of patient, which kind of group can use the special treatment to get the high survival rate.
Okay, thank you.
Thank you. I'm going to stop the questions there. If you have any more questions about either of these studies, please put them in the chat. Thank you, Dr. Liu, for your time here. So I'm going to move on to going back up to the first one, right? Wenshuo, Dr. Wang, do you want to go on your study?
Yes.
All right, we're going to go backwards here.
Thank you everyone for giving me this opportunity. Can everyone hear me?
Yep.
Yes.
Okay. I'm Dr. Wang from the same hospital as Dr. Liu. Today, the content of my proposal is a study on the post-operative lipid levels and the durability of prosthetic valves. The next slide, please. Worldwide, the prevalence of heart valve disease in the population shows a gradually increasing trend with the rise of the age level, as shown in the left figure. At the same time, with the increase in the surgical rate of patients, both the usage quantity and the proportion of prosthetic valve has significantly increased, as shown in the right figure. A similar trend is also observed in China. The annual usage quantity of bioprosthetic valve has increased from 22,000 cases in 2019 to 40,000 cases in 2021. Next slide, please. After implantation, bioprosthetic valve may develop dysfunctions. According to whether there is a hemodynamic disorder, it can be divided into surgical dysfunction and non-surgical dysfunction. When a bioprosthetic valve with dysfunction shows severe stenosis or regurgitation, it's defined as valve failure. In the above process, blood lipids plays an important role through direct deposition and induction of inflammatory reactions, as shown in the blue box in the right finger. Next slide, please. Structural bioprosthetic valve dysfunction has highest incidence in rate among patients, so the abbreviation SVD is often used in the exciting studies. There is a controversy in current research regarding whether blood lipid levels can affect the durability of valve. The reviews shown in the left figure hold that hyperlipidemia is a risk factor leading to the SVD, while the prospective studies on very limited cases on the right find that reducing blood lipid levels cannot extend the service life of the bioprosthetic valve. Next slide, please. Therefore, my proposal is to clarify the impact of blood lipid levels on the bioprosthetic valve and the difference in the impact of various subtypes of blood lipid. Meanwhile, based on this, a prediction model will be established to guide the post-operative blood lipid control strategy. Next slide, please. This workflow diagram presents the data collection process during the research. The required baseline data include demography information, bioprosthetic valve implantation information, as well as the blood lipids, blood pressure, and echocardiogram data upon the discharge. The content of the annually following up include blood pressure, blood lipid, and echocardiogram data. Among them, the criteria of diagnosing bioprosthetic valve dysfunction using echocardiogram data has shown in the red box. Next slide, please. The OHDSI fields corresponding to the information collection process are shown in this slide. Thank you very much.
Thank you, Dr. Wang. Anybody got questions or comments on this particular study?
So yeah, let me start first. Okay, so this is really interesting study because I'm interested in the cardiology field, even though the previous two studies from of the Dr. Liu were interesting too. Anyway, in terms of the data availability, I have concerns about the availability for the data in the echocardiography and a more detailed data for the valve itself, like the size of the valve or the model of the valve or the version of the valve are not available across the data network. That's the concern of mine. That's it.
Awesome. Cynthia. You're on mute.
Yeah. Okay.
Oh, there you go.
Just unmuted. Okay. Yes. After a valve implant, I imagine there's a lot of drugs that are given for immunosuppression. And so is there a very standard protocol for drugs? And if there isn't, then I think you need to capture those drugs as potentially confounders in the outcome you're looking at. Over.
Thank you. Anyone else? All right, if we can go to the the next one, which is from Beijing University. So Dr. Chen or Chan and Dr. Sun. Sorry, there we go. Xiaowei, are you here?
Everyone can hear me.
You're very quiet.
I will start. Hi everyone, my name is Xiaowei Chen from Peking.
Oh,
You sound very far from you sound very far from the speaker.
right.
Okay.
It's better.
It's a great honor to make a presentation today. My topic is the effect of angiotensin receptor blocker on the development of chronic diabetic complications in patients with type 2 diabetes, a target trial emulation study. Now, I will introduce in 4 parts. The first part is the background. Previous RCT suggests that ARB may prevent diabetic complications such as retinopathy and nephropathy. However, some studies report high dose omestin in diabetic patients may lead to an increased cardiovascular risk. These findings remain inconsistent, and there's a lack of population-based studies using real-world data. Unlike traditional real-world studies, employing the target trial emulation TTE framework can reduce potential bias and enhance the credibility of causal inference. Now, the next, our study aims to conduct a target trial emulation study using the Indo-Regional Healthcare Database Diabetes or CDM to investigate whether the use of ARB, especially omestin, can prevent the occurrence of chronic complications among type 2 diabetes. The next part is we will use the Indo-Regional Healthcare Database Diabetes CDM. You can see it is in Ningbo City, Zhejiang Province in China. Now, the next part is a brief introduction to our database. It's a comprehensive and stable database capturing healthcare data from over 98% of the local population. Now, next part, I will introduce our study protocol. We will emulate the road damp trial, replicating its design with inclusion and exclusion criteria and other of over 6 elements. So this is the study inclusion and exclusion standard. Our TTE tries to emulate the original RCTs as much as possible and relax its appropriability. Now the next part is our intervention. In our TTE, we will compel patients initiating omestin treatment to those who did not initiate omestin throughout the study period. Our primary outcome in the TTE was the new onset of retinopathy. Additionally, secondary outcomes such as renal function decline, CVD events, and combined CVD and renal outcomes. Next, our study adopts a sequential trial emulation design, conducted monthly from January 2018 to December 2022. At the start of each month, eligible patients are identified. Baseline characters will be assessed, and follow-up begins, continuing until an outcome occurs. Well, to control confounding, we performed 1-to-1 propensity score matching at each sequential trial initiation, balancing baseline characteristics. The standardized mean difference will be used to ensure adequate balance. Well, for our primary analysis, we employed ITT and analysis using marginal structure models, MSM, with pooled logistic regression to address time-varying confounding and estimate causal effects. Well, the subgroup analysis explored potential differences by age, sex, and baseline cardiovascular risk disease. While sensitivity analysis include PP analysis and alternative matching strategies to test result robustness. Well, finally, we will evaluate the consistency of our real-world evidence from TTE with the original RCT results. We will use 3 standard indicators from the US RCT duplicate project, such as regulatory agreement, estimate agreement, and standardized difference. The fourth part is our anticipated results. So here you can see in our slides. So in the next step, we will expanding our evidence beyond target trial. We plan to explore the effectiveness of omestan among elderly patients over. So next slide, please. Thank you. We will aim to explore the effectiveness of omestan among elderly patients over 75 years old. In East Asian groups and those with significant comorbidities such as hypertension and renal disease to better inform clinical decision making. That's all. Thank you for your attention.
I gotta unmute myself. So I'm gonna be Chan this time to start with the question, but thank you very much for that presentation. And I don't understand studies that well, but it seems like you're already running this study in China with the Ningbo data already. So if my assumption isn't wrong, are you looking at to rerun those with other OHDSI data, or are you looking at hitting your next steps with the OHDSI data?
Yeah, and this protocol will be done in the Ningbo in China, and we want to seek to other corporations such as in Europe or in USA or in Japan or in South Korea.
Mm-hmm.
So
okay, thank you. Chen.
thank you.
So you've already conducted the study, or you are gonna conduct this study in your database, and then you wanna recruit more database partners? Have you done or?
就是你已经写完了这个 study， 还是你现在没写？ And then 你们会放在那个宁波里面跑一趟，才给我们去跑其他的国家的。
Yeah, we will do this study in Yingzhou, Ningbo, and then we will share our code to other corporations.
Got it.
So they haven't done it yet, but that's what they plan on doing.
Okay. Thanks for the wonderful presentation, Dr. Chen. And to disclose my conflicts, I have recently been requested by a pharmaceutical company to conduct a very similar study targeting olmesartan. So that's my COI. And I think this is very well designed study, but about the of the feasibility, we in OHDSI network, we've not developed the sequential trial framework. So just and I think that if you compare, if you set that active competitors such as like calcium channel blockers or other ARBs, then it'll be much easier, and it can provide much more reliable evidence, because in this study you've not defined the inclusion what is that? the reason why patients are using the ARBs, such as you need to define the patients should have that hypertension at least. So I think if you can define the active comparator, that will be much easier for us to conduct a study.
Yeah, actually, our study is try to emulate the original RCT in the RCT the inclusion and exclusion criteria. It is you can see in the slide. Yeah. The inclusion and exclusion criteria. The patients maybe not have hypertension.
Yeah, I agree, but it's an RCT. So, you cannot emulate this RCT by using just, observational database because you do not conduct an intervention. So, I do understand the emulation of RCTs, but it's very hard to, emulate this this type of RCT. It does not have any indications for the ARB.
So, is the sequential trial are hard to done or conduct?
Yeah, there are two problems. First of all, there is no sequential trial framework in current OHDSI network. And the second, because it does not define the clear indication for ARBs. So in the real world, in routine clinical practice, we do not use ARBs based on this inclusion criteria. So maybe it will be much better to define the clear indications compatible with the routine clinical practice, such as hypertension.
Okay, I know. I will revise my protocol. And if I want to revise my protocol that the control group with the active comparator to replace the sequential trial, is it proper to?
Yeah, and then I can recommend a very similar trial targeting olmesartan and then based on targeting the very similar outcomes that using the comparators, and then I can send that trial.
Okay, thank you.
Thank you, Chan. Anyone else have any comments on this particular study? If not, thank you very much. We're going to move on to the next study, which is Professor Yongqi Zheng. Are you here?
Can you hear me?
Yep, perfectly.
Yes, okay. So hello everyone, I'm Yongqi Zheng from Peking University. And today my presentation focuses on safety outcomes of semaglutide in type 2 diabetes using regional health data, a target trial evaluation. So the first, next slide please. The first part is background and significance. And semaglutide as a GLP-1 receptor agonist not only lower blood glucose, reduces weight, and improves metabolic abnormalities, but also reduces cardiovascular event risk. Since cardiovascular events are the leading cause of mortality in patients with type 2 diabetes mellitus, they significantly impact patients' quality of life and prognosis. International research has demonstrated that RCTs such as SASN6 and SELECT trials shows that semaglutide significantly reduced MACE. Real-world studies have yielded the similar results. However, high-quality RCTs and large-scale real-world studies remain limited in China. To address this gap, we applied the TDE. It considers biases existing in real-world study and improves the accuracy of drug effect estimations. Importantly, it allows for progressively relaxed inclusion or exclusion criteria to evaluate drug effectiveness in both target and broader populations. This study addresses the lack of large-scale safety data on semaglutide in Chinese T2DM patients by applying TDE, expanding the population in additional age groups. The incorporating diabetes complications as primary outcomes. And the second part is study design and methods. And this is our data source. It's just similar as the ㅍStudy, and we use Ningbo Regional Health Information Platform, and we try to have a try in this platform, and we will share the code with others. And we strictly adhere RCT-based inclusion criteria, ensuring alignment with RCT standards with the contents of the database. And in the TDE analysis, the observation groups receive semaglutide treatment, while the control group receive DPP-4 inhibitors. Since blinding is not feasible in real-world studies, we applied principal score matching using a one-to-one nearest neighbor matching method with a Kepler weight set at 0.05. The SMD was used to assess the balance of baseline characteristics. We adopted an active comparator design where new users were defined as patients who had not received GLP-1 raise or DPP-4I during the baseline period. The index date was defined as the first prescription day, which fell between January 1st, 2020 and December 31st, 2023. Follow-up began 1 day after the index date and ended at the earliest occurrence of 52-week follow-up completion, an outcome event, death, or study termination. Primary outcomes were consistent with RCT criteria, including a composite endpoint of cardiovascular death, non-fatal myocardial infarction, and non-fatal stroke. Given the potential inaccuracy of cause of death determination in ARTERY-D, all-cause mortality was also assessed. For statistical analysis, we employed an ITT approach using random forest imposition for missing data and applying cost model for primary analysis. And to evaluate the consistency between TDE and RCT results, we use 3 key metrics: regularity,
一般来说，我们
Okay, so the US RCT WK project defined this as follows. And one of the key innovations of our study is the expansion of indications for semaglutide. Our study extends the target population to include T2DM patients aged 30 to 50 years. This adjustment allows us to better assess the semaglutide safety in a broader age group. Additionally, our study introduces a novel focus on association analysis between semaglutide use and diabetes-related complications. We try to use cost regression models to examine the potential relationship between semaglutide and DR hypoglycemia and malnutrition, providing new real-world insights into its long-term safety profile. And that's all. Thank you.
Thank you. Anyone got any feedback on this? My assumption is the same thing since it's Ningbo. You guys are going to run this on the data and then ask the community to run it on their data, right?
Yeah.
Qi.
I see this study and the one the last one have the similar methodology, TTE. Do you have any intention to use the OHDSI established methodology like population analysis? All the R package has been developed, been used. Do you have? You have no intention, you want to use this TTE instead of using using OHDSI tools like Atlas, population level analysis, or?
So I don't think it's not that they don't have any intention. I think that's the purpose of these calls, right? They don't understand. None of our collaborators here really understand the OHDSI tools or what's
I see.
available. So
I
thank you for that feedback. So one of the feedback here is maybe we need to look working it with the Beijing group, right? Working on showing them how some of the OHDSI tools work to potentially achieve many of the same goals that they're trying to do, right? So Chen. Sorry, you're going to be my last comment here because I got to move on. I got 2 more.
I just want to echo what Patrick wrote in the chat. So, because we do have a legend diabetes study before. So, and then in that study, we've investigated the cardiovascular outcomes of semaglutide compared with other anti-diabetic drugs, including DPP4 inhibitors. So, in this study may replicate that previous OHDSI study in more data purchased from China. So we can do that, and it is it is also important, I believe. But if you set the different outcomes such as atrial fibrillations, which is my one of my interests can be would be better. So if you can modify the outcomes, or if you're looking for other outcomes beyond the previous legend diabetes study, that might be better, but it's up to you. It's very well designed, very clear study. Thank you.
Awesome. Thank you. We're going to move on. If we can have Dr. Liang, if you want to talk about your study. Yep.
Okay. Good morning, everyone. It's my honor to share my project. I'm the teammate of Professor Gong, and today I'm going to share it is retrospective study on the impact of BMI trajectories on long-term prognosis in CKD patients using electronic health records. So I will introduce the global CKD burden. CKD affects almost 700 million people globally and 82 million in China, which is posing a significant public health and economic burden. The progression of CKD leads to end-stage renal disease, requiring costly treatments like dialysis and transplantation. So, and obesity, as we all know, is an independent risk factor for CKD progression, increase the risk of renal function. But the existing study have focused on single time point BMI measurements, neglecting the dynamic nature of BMI trajectory. So this project is focused on long-term BMI patterns, may provide better predictive power for CKD outcomes. So with the electronic health records data of a wealth of longitudinal patient information, we run the methods like group-based trajectory modeling enable to detail the trajectory analysis. So how do we identify the BMI trajectory patterns? Firstly, we need shaped time frames for trajectory analysis. We distinct BMI trajectory patterns in CKD patients over 3, 5, and 10 years. And then we investigate associations with renal function decline. And we determined the CKD clinical intervention threshold. So finally, we can investigate association with cardiovascular events and investigate association with all-cause mortality. Next, thank you. The previous. Yeah, thank you. We conduct a retrospective cohort study using EHR data. So we inclusion criteria is like this over 18 years with CKDs stages from 1 to 4 stage, and we with over 3 BMI measurements. And the inclusion criteria is with serve competitive organ and organ transplants and so on. And next, how we use the method of GBTM. What is GBTM? It is group-based trajectory modeling. It is to classify BMI patterns into distinct groups, such as stable, rising, and fluctuating. And then GBTM allows for the identification of different BMI trajectory patterns within the patient population. And we use and find outcome analysis. We can use Kaplan method, survival curves, and focus regression to find the outcome result. Finally, please next slide. We expect outcomes. We can distinct BMI trajectory groups, and then we can quantitative links with the outcomes, and we can give a clinical actionable thresholds, and we hope can publish a high impact publication. That's all. Thank you.
Thank you. Do we have any feedback on this particular study? No? All right, we're going to move on to the last one that we have. If we can have Professor Luo. Are you here?
Yes, I'm here. I'm just adjusting my microphone. Can you hear me now?
Yes, perfectly.
Yes. Thank you. I'm going to present this study on studying the disease trajectory of type 2 diabetes with a transformer-based model. I'm from Department of Endocrinology of the First Affiliated Hospital of University of Science and Technology of China, and I'm Sihui Luo, as introduced. And so type 2 diabetes is the most common chronic metabolic disease worldwide, significantly impacting patients' quality of life and leading to severe complications such as cardiovascular diseases, kidney disease, and retinopathy. Traditional screening method or subgrouping methods are costly and often lack sensitivity, so making it very difficult to identify high-risk individuals in a timely manner. Next slide, please. So to address these limitations, we turn to the real-world data and use artificial intelligence to do risk prediction. And we can see in this slide that in 2018, Professor Leif Group from the Lund University has reclassified diabetes mellitus into 5 pathological subtypes using 6 accessible clinical parameters. And subsequent studies by the GDS cohort that reveals the 5 years follow-up, that the new type 2 diabetes subtypes exhibit dynamic variability through and changes of phenotypes and their risk of complication. Maybe this is due to the treatment. So next slide, please. So the existing risk prediction models, as we shown in the previous slide, that it still lacks of sensitivity, and it is not readily to be used in the clinical practice. So it is most relied on static data and also fail to utilize the time series information of the disease fully. As our study aims to fill this gap by combining the OHDSI database and the deep learning technology to construct a precise and dynamic diabetes risk prediction model, supporting early screening and personalized intervention of complications. Next slide, please. Our study employs an retrospective cohort design. We construct the disease trajectory of type 2 diabetes patients based on real-world data, analyzing large-scale patient clinical data with machine learning and deep learning method. and to establish a dynamic disease trajectory model to explore disease progression at different time points. And here is our patient inclusion and exclusion criteria. We mainly include patients aged over 18 years with a confirmed diagnosis of type 2 diabetes, and we exclude mainly those patients diagnosed with type 1 diabetes, gestational diabetes, and other special types of diabetes. And also we exclude those diagnosed with rheumatic diseases during the study period. And we also exclude those missing crucial data, follow-up time less than 30 days, and who receive renal replacement therapy before or within 10 days of their first visit. And we also exclude those with end-stage organ failure at the baseline or within 3 months before their first visit. Next slide, please. Thank you. And our primary endpoint will be the reclassification and progression of type 2 diabetes, including the time notes of diabetes diagnosis and changes in the related disease status and outcome-based reclassification of type 2 diabetes. And we will also explore the secondary endpoints, including the incidence and severity of diabetes-related complications. And our exploratory endpoint will be the assessment of the drug treatment effects, including the efficacy of various drugs like insulin, SGLT2 inhibitors, and GLP-1 receptor agonists, and other treatment effects. Next slide, please. We have not this is our data analyze methods framework. And so we focus on data preprocessing and integration. We also will establish new modeling methods using the state-of-art deep learning methods. And we have already have the techniques of the distributed computing methods, so that we can use the multi-center data across the OHDSI participating centers. Next slide, please. In conclusion, our study leveraged the using the real-world data, and will be using the advanced AI techniques to develop a dynamic and precise risk prediction model for type 2 diabetes. And I hope that this model will have the potential to significantly improve early screening and personalized intervention strategies for type 2 diabetes patients. And ultimately, this strategy will enhancing the patient outcomes. Thank you very much.
Thank you. Love it when AI is mentioned somewhere. So
Yeah.
Anyone have any comments here?
So this is very interesting study, but we may need more clear outcomes, whether it will be it targets them, the incidence of diabetes or the occurrence of diabetes or its outcomes. So if you can provide a more clear outcome, that will be helpful.
Yes, this is a very good suggestion. I'm sorry that I didn't present it clearly. We mainly focus on outcomes such as all-cause mortality, if possible, and we also focus on the outcome of incident CVD outcomes, incident CKD, and incident diabetic retinopathy, and so on. Yeah.
I think Patrick had a comment in the chat that one of the things that we may want to look at is the OHDSI tool, where we have a prediction, a PLP, right? A patient level prediction model framework already in packages available to potentially help design what's the appropriate target and outcome cohorts, right? So that's a feedback, I think, for overall for many of these studies, is that we may want to look at, based on your study, what OHDSI packages already exist that can help you, because a lot of work has gone into it. They've all been verified. They've all been validated. So it would be good to see those being used and taught in the APAC side. So any other questions for Professor before we let her go as well? No. All right. I want to thank you everybody for those who presented and those who provided feedback and listened in. Our next step here. So again, these studies are community studies that we are hoping to launch sometimes in the coming months or weeks, who knows. Our next step here is what we will probably see is we are going to put a poll out there for folks to vote on which ones we may walk on first. We're not saying that we won't work on them all, but we can't focus on all of them at the same time, right? So we're going to put a poll out there to see who has an interest in, one, helping out, two, helping us determine as a community which ones we're going to work on first, right? And then we'll come back to all the presenters with some kind of schedule and some next steps. All right. Thank you very much. This was a very packed call. Thanks for those who stayed up until midnight, because I know quite a few of you guys on this call from the East Coast. Thank you very much for that dedication and support for the OHDSI APAC community. So thank you, everybody. All right.
Thank you very much.
Thank you.